Hello, welcome to the lecture course CH-102 Organic Chemistry for F.Y.B.Sc class. In previous lecture, we have discussed about the physical and chemical property of geometrical isomer. Also, we have discussed about the physical property of alkene compound. In this lecture, we are going to discuss about the laboratory preparations of alkenes. So, major source of organic chemical is a petroleum and natural gas. Petroleum and natural gas rich in alkene and aromatic hydrocarbons. After cracking process, when undergo means alkene compound when undergo cracking process, we get the alkene compounds. Alkene undergo cracking process, alkene is formed. Alkene undergo cracking process, we get the alkene compound by cracking process. So lower members, particularly ethylene, propylene and butylene, that form alkene by cracking process. But to prepare higher alkene members, we consider the laboratory preparations method. So lower members, ethylene, butylene, propylene, this member also prepared, also higher member prepared by laboratory preparations method. So, in laboratory preparation method of alkene, we use the two approaches here. So by two approaches we can prepare the alkene compounds. First is elimination reaction and second is the addition reaction. So alkene compound when undergo elimination reaction, when adjacent atoms or group is eliminated from alkene, we get the alkene compound. X, Y. So this kind of elimination reaction is called as a one-to elimination reaction. One-to means group 1 and group 2 is eliminated. So one-to elimination. So with the help of this elimination reaction, we can prepare the alkene compound. So in elimination reaction, carbon-carbon single bond convert into carbon-carbon double bond. So this is the first approach we can use to prepare the alkene compound. Second is addition reaction. So addition reaction here is also called the reduction reaction. We call reduction. So here in addition reaction, we take the starting material, that is the alkyne compound. Alkyne compound undergo addition reaction means reduction reaction. Addition. So after addition reaction, cis alkene, cis and trans alkene. So by this addition or reduction reaction we can prepare the alkene compound from alkyne. So in this addition reaction, nature of product is depend upon reagent used and reaction condition employed. So by these two approaches we can prepare the alkene compounds. So we write here preparation of alkene. So there are two approaches. First is the elimination reaction. Second is the addition reaction. This may be called reduction. By elimination reaction, we can prepare the alkene compound. So which elimination reaction we perform here? Three type of elimination reaction. Dehydrohalogenation of alkyl halides. This is the first. Second is that dehydration of alcohol, and third is the dehydrogenation of vicinal halides. From alkyl halide, with the help of soluble reagent, if you remove HX, means HX group. So removal of HX group is nothing but dehydrohalogenation. So by this approach we can prepare the alkene compound. Second is the dehydration of alcohol. Dehydration of alcohol. By this way, dehydration is loss of water molecule. From alcohol, if we lose the water molecule, we can prepare the alkene compound. Vicinal halides. When adjacent carbon bear the halogen groups, that time we call vicinal halides. Dehalogenation means loss of X2. By this we can prepare the alkene compound. Loss of X2. Loss of both groups X2. So by this we can prepare the alkene compound. Second approach, that is addition reaction. That is the reduction reaction. So here from alkyne we can prepare the alkene compound. So first is the addition of hydrogen in presence of catalyst like nickel, palladium, platinum. We can prepare the alkene compounds. So Lindner's catalyst. By this Lindner catalyst, we can prepare the cis alkene. For cis alkene, we can use the Lindner catalyst. This is a special type of palladium catalyst. With the help of this, we can prepare the cis alkene. lithium or sodium in liquor ammonia. With the help of this, we can prepare the trans-alkene compound. So we start to discuss here. First, by elimination reaction, how we prepare the alkene compound. By elimination reaction. First is the form alkyl halide by dehydrohalogenation reaction. So alkyl halide compound, when undergo reaction with strong base like alcoholic KOH or sodium amide, undergo elimination reaction and form the alkene compound. This is the general alkyl halide. So this alkyl halide when heated with alcoholic KOH solution or sodium amide or alcoholic KOH. So here this is the group which is attached to, this is the alpha carbon, this is the beta carbon. Okay. So from alpha carbon we eliminate the group X, means halogen atom we eliminate, and from beta carbon we eliminate the hydrogen. So this kind of elimination is called the beta elimination reaction. So hydrogen atom is eliminated from beta carbon. So beta elimination reaction. So when alkyl halide compound is heated with alcoholic KOH solution or sodium amide solution, alkyl halide compound undergo elimination reaction. Alkyl halide compound undergo beta elimination reaction. From alpha carbon halide atom, halogen atom, from beta carbon hydrogen atom is eliminated. So this is called beta elimination reaction. So overall HX is eliminated here. So in this way we can convert carbon-carbon single bond into carbon-carbon double bond. So next is the, suppose if you consider the example of one bromopropane. Okay, this one bromopropane is heated with alcoholic KOH solution. There is a loss of H and Br. From alpha carbon loss of Br and from beta carbon loss of hydrogen. So overall loss, there is loss of HBr. So in this way, from one bromopropane we can prepare the propene compound. Propene we can prepare. Next example, we consider here that is a 2-bromobutane. Two bromobutane when heated with alcoholic KOH solution is undergo elimination reaction. But in first case, we observe only one type of beta hydrogen. But in this case, there are two bromobutane, there are two types of beta hydrogen. So this is the alpha carbon, this is the beta hydrogen, this is the beta dash hydrogen. So obviously we can see that there are two types of beta hydrogens. So in this case what happens? In first case we can observe only one type of beta hydrogen. So loss of both beta hydrogens are possible here, and because of that we get the two product here. Which is the major or which is the minor? We have to decide here. Firstly, loss of this Hb hydrogen. If we lose this Hb hydrogen, that can one butane is formed with formation of HBr. Loss of Hb dash hydrogen. Two butane is formed. Two butane exist in two forms, that is cis and trans. After loss of Hb dash hydrogen, two butane is formed. Two butane exist in two forms. We know that very well, cis and trans two butane. One butane compound is from 20%. Two butane compound is from 80%. So trans compound is formed in major proportion here because of stability. Is formed in minor proportion. So when two type of beta hydrogen present, we get the three product: one butane, trans two butane and cis two butane. So which is the major? So major product is decided by the Sether's rule here. That is nothing but orientation of double bond. Double bond is formed majorly at which position? So orientation of double bond. This is decided by the Sether's rule. Sether's rule says that in elimination reaction, when two or more product is formed, the Sether's decided which is formed in major proportion. Statement of Sether's rule is that in an elimination reaction, more stable alkene, in an elimination reaction, more substituted alkyl is formed as a major product. In an elimination reaction, more substituted alkene is formed as a major product according to Sedgwick's rule. So, 2-bromobutane undergo elimination reaction. So, according to that, 2-butane is formed as a major while 1-butane is formed as minor. So, 1-butane is attached to one alkyl group. 1-butane is attached to one alkyl group, means mono substituted alkene. While 2-butane is attached to two alkyl group. So, disubstituted alkene. This is a mono, this is disubstituted alkene. So, according to Sedgwick, more substituted alkene means 2-butane alkene is the most substituted alkene here, disubstituted. So, that is forming major proportion. So, stability of alkene is dependent upon number of alkyl group attached to double bond. Number of alkyl group decide the stability. More alkyl group is attached, that time stability of alkene is increases. So alkyl group is electron donating group. So they increase the stability of alkene. So obviously disubstituted alkene is a more stable alkene than monosubstituted alkene. So we can restate the Sedgwick statement in this way also for elimination reaction. That is in elimination reaction, more stable alkene is formed as a major product. What is the restatement? According to this statement, more stable alkene is formed as a major product. The alkene which is attached to more alkyl group is the more stable. So disubstituted alkene is more stable than monosubstituted alkene. So here 2-butane is a major product while 1-butane is a minor product according to Sedgwick. If you consider the stability of alkene, alkyl group is attached to alkyl group to overall 4. Tetrahydral alkene is more stable than trihydral alkene, which is more stable than dihydral alkene, which is more stable than this type of dihydral alkene, which is more stable than monohydral alkene, which is more stable than this ethylene compound. In this way, we can write the stability of alkene. So, this is about the orientation of double bond according to Z-fluid. Next is the next point from dehydrohalogenation of alkyl halides. Reactivity in elimination reaction. Reactivity in elimination reaction. Orientation of carbon-carbon double bond is not only depend upon stability of alkene but also depend upon nature of alkyl halides and nature of halogen atom. Nature of alkyl halide means when you move from primary to secondary, secondary to tertiary, primary, secondary and tertiary. So when you move from primary to secondary, secondary to tertiary, there are two effects we observe. First is that number of beta hydrogen is increases from primary to secondary, secondary to tertiary. This is the first effect. From this to this, number of beta hydrogen increases. And when number of beta hydrogen increases, second effect is that alkyl halide compound undergo elimination reaction. There is a more chances that alkyl halide compound undergo elimination reaction. Means primary to secondary, secondary to tertiary. Tertiary alkyl halide compound easily undergo elimination reaction as compared to secondary. Secondary undergo elimination reaction more easily as compared to primary alkyl halides. So on this basis we can say that tertiary alkyl halide is more reactive toward elimination reaction than secondary than primary. So reactivity order in elimination reaction, that the tertiary alkyl halide is more reactive than secondary, secondary is more reactive than primary alkyl halides. So this is the first factor. Second factor is that nature of halogen atoms. Nature of halogen atom means alkyl halide compound is more reactive than alkyl bromide. Alkyl bromide is more reactive than alkyl chloride. Alkyl chloride is more reactive than alkyl fluorides. So in alkyl halide, the bond between carbon and iodine is present. In alkyl iodide, bond between carbon and iodine, while in alkyl fluoride, bond between carbon and fluorine. So size of carbon is fixed here, atomic size of carbon is fixed, but iodine has the largest atomic size. In fluorine, you know that fluorine has the smallest atomic size as compared to iodine. Carbon atomic size is fixed. So because of atomic size, fluorine has a small atomic size, so bond length. So bond between carbon and fluorine is the shortest bond here. This bond is very short bond. So shortest bond. Okay. Here this is the longest bond. As this bond is longer or longest, the bond between carbon and iodine is easily broke. While bond between carbon and fluorine is the shortest, that bond not easily break. So on this basis we can say that alkyl iodide is more reactive than alkyl fluorides. So this is the two factors which decide the reactivity in elimination reaction. So in next lecture we will discuss about the remaining two preparation method, that is the dehydration of alcohol and third is that by dehydrohalogenation of vicinal halides. Okay, thank you.